Okay, looking at the homework from 3.7, graphing the inverse and state domain and range. For number 1, we're given this R is 4 points, and we're supposed to talk about the inverse. So the inverse is take each point and switch it. So the y becomes the x becomes the y, and we switch each one of these, and we should write them down. It asks for the domain of the inverse, so those are the x values of the inverse 2, and I don't have to write 2 again, -1 and -2. So I listed the x values, that's the domain. I listed the y values, that's the range. It asked me to graph it. It's 4 points. So I graph 4 points. I graph the inverse points. Same deal with number 2. I'm given 4 points. I'm going to write out what the inverse is. I'm going to take each point. So instead of -3, 3, it'll be switched. X and Y switched. 3, -3. -1, -1's the same. 1, 0, and 4, 4 is the same. So some of these didn't do very much. The domain will be a list of the x values. So 3, -1, 1, and 4. 3, -1, 1, and 4 are the x values. And then the range is the y values or the second values. So -3, -1, 0, and 4. And they asked me to graph it. So those are 4 points. I've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so 3, -3, 1, 2, 3, down 3, -1, -1, +1, 0, and 4, 4. They just wanted us to graph the inverse function. For number 6, we're given x equals negative the square root of y. Same directions. I'm supposed to graph the inverse, state, domain, and range. So first I have to find the inverse. And the inverse is simply switching the x's and the y's. So instead of writing x, I switch to y. And then where y is, I write x. So this looks like the square root function. If you check your parent functions, the parent function looks like this, but ours has a flip. So it really goes like this. So I've actually graphed it already. There's my graph. It's flipped over. And so domain and range, I'm going to take from that graph. The domain of the x values, and it starts at 0 and goes to infinity. So x is greater than or equal to 0. The range is, it starts at 0 for y and goes down. It's still going to go down. So this is going to be y is less than or equal to 0. So it goes down. X goes up, y goes down. It's not really that straight. It kind of goes like, I don't know. That's a little bit better. So for 6, we could have written it in interval notation as well. So that would be starts at 0, goes to positive infinity. This one's less than 0. So it ends at 0, negative infinity, stops at 0. That would be interval notation for number 6. For number 7, we need to again switch the x's and the y's. This is what's given, and we're going to switch them. So we have x equals 1/2. Instead of writing x, we write y, and then solve for y. So I'm going to put a line here to differentiate between the two. I'll add 3 to both sides. X plus 3 equals 1/2 y. Multiply both sides by 2. Now note the entire side is multiplied by 2. The 2 and the 1/2 cancel, so y equals 2x plus 6. So if I want to graph that, it's the equation of a line because it's to the first degree. So I'm going to go to 6, 1, 2, 3, 4, 5, 6, and go up to over 1. So the graph of my line goes like that. The domain and range for lines is everywhere. So the domain is all real numbers and the range is all real numbers because it goes up forever and down forever and left and right forever. 8 says y equals negative x plus 1. So a similar type of problem. We need to switch the x and the y's. So x equals negative y plus 1. If I subtract 1 from both sides, I have x minus 1 equals negative y. We have to undo the negative y and say negative 1 on both sides makes it y equals negative x plus 1. So to graph this one, we go to positive 1 and go down 1 over 1, graphing a line. So y-intercept and slope is down 1 over 1. Again, the domain is all real numbers and the range is all real numbers. For number 8. Number 9, y equals the square root of x plus 2. So this one I actually want to graph first as the original function. So the original function is the square root function up to. So normally the square root function starts at 0 and kind of looks like this. This one is moved up to. So I'm going to go up to and draw what it looks like. There we go. So you could get that from your functions chart. Now let's look at domain and range for the original function. The domain is going to be, well, we're starting here at x equals 0 and going this way, so we're saying that it goes from 0 to infinity. The range, there's nothing down here for y. So it starts at 2 and goes up. So it starts at 2 and goes up. That's the range. And that's going to be important when I look at the inverse function. So let's do our magic here where we switch the x and y. X equals the square root of y plus 2. We need to solve this for y. So subtract 2. X minus 2 equals the square root of y. And to fix y, to get it all by itself, right now it's got a square root on it, we need to do that little tiny inverse, which is to square both sides. And that will undo the square root. So we have y equals x minus 2 squared. Because I've already figured out the domain and range for the original function, I already know the domain and range for this inverse function. Because just like the x's and y's switched right here, the domain and range switch. So the domain for my original function is 0 to infinity. It goes with x. Now it goes with y. So I can write 0 to infinity for my range. Now I'm going to look at the range for the original function. That was y. It got switched to x. So 2 to infinity is the domain. So not only did the x's and y's switch in the equation, but the x's and y's for domain and range also switch. When I go to graph this, this is a parabola because it's a square. So I know what a parabola looks like, but I only have half of it. See how this is only half of a parabola going sideways? I'm only going to have half of my parabola on this side as well because of this limited domain and range. So when I look at this parabola, it has a right shift, opposite math inside the parentheses. So instead of starting at 0, 0, it starts at 2. And I'm only going to use the domain from 2 to infinity. So it's only going to be the part of the parabola that goes this way. Now, because I've graphed both of them, this is a great example of how they reflect over the line y equals x. That is a thing that happens with every function and its inverse when you graph them, and that's because the x's and y's switch. So they reflect over y equals x because they undo each other. And x and y switch. So check your number 10. I've got all my points are switched. I graphed them. The domain for the inverse is going to be 2, -1, 4. Those are the x values. The y values for the range are 4, 3, -2, and 2. And they're put in set notation because that's how they gave it to us in the problem. In number 30, we're supposed to find the inverse. So let's call this y equals 4x minus 3 so that we can switch them out. X equals 4y minus 3. We just switch the x and y's. Now we're going to solve for y. Add 3. X plus 3 equals 4y. Divide by 4, and we're done. X plus 3 over 4 equals y. And if we want to use the same notation, we would say that g inverse of x equals x plus 3 over 4. So that's for 30. And then 35 is given in function notation, but we can replace that with y. Then we need to switch the x's and y's, so x equals y plus 5 over 2. If you think back to Algebra 1, we learned how to make this into two fractions that we could cross multiply. That makes the fractions go away pretty easily. So we're going to multiply and get 2x equals y plus 5. Or you could have multiplied both sides by 2. That also works. Now we solve for y by subtracting 5. So 2x minus 5 equals y, and we can write it in function notation. The inverse of x equals 2x minus 5 for 35. Okay, so that's going over the first homework from the inverses, and then we're going to do more with inverses, do more with the graphs and things in our next lesson.